analog converter. What we need to do from another port, we are going to take another analog signal, that is your analog signal that will be going to convert into digital. Here we have a digital pulses in the 8051. We need to transfer digital pulse with respect to analog output I need to get. Here what I am going to do with the ports 1.0 to port 1.7 is the input port for the output port of 8051, and input port will be D0 to D7 of 0808 IC. We have already discussed pin number 4, 5, 6, 7, 8, 9, 10. These pins are the input pins what we are going to study in the last class. Okay, it will be going to take the inputs, and based on the working of that, it will be going to generate a analog signal. How it will be going to convert from analog signal to digital signal to analog signal. It will be decoder. It will be realizing filter. Make use of that. It will be going to convert an analog signal. So here we are going to get an analog signal. We are going to use one operational amplifier. Why we need to use operational amplifier here? In order to check the voltage level. Here for sometimes it will be going to get a low voltage level. It will be going some losses in the IC. That is why we are going to use one amplifier to increase the strength of this signal. Okay, how exactly it will be going to convert an analog signal? Here we have a relation. I out is equal to I reference into D7 by 2 plus D6 by 4, like that, so on. If you substitute all 1, 1, 1, 1, 1, you will get a maximum current you are going to get it. Okay, can you substitute D7 to D0 all once you take, and check for the output? I reference will be your 2 milliamps. Can you tell me the I out output current? Maximum you will get 1.99 milliamps you are going to get. If you substitute 1, 1, 1, 1, 1 all ones, like that, you will get from 0, 0, 0, 0, 0, 0 to 256 times you are going to get. That many levels of voltage you are going to get. For example, if I am going to take one sinusoidal signal, it will be vary from 0 to maximum. Whatever the different values I need to get, that I am going to vary with respect to these digital bits. Okay, for example, now can you take D0 to D7 will be 1111. Can you check for I out? Please, can anyone respond? Take D0 to D7 will be 11111. Check for the I out, output current. Output current. One by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 plus 1 by 64 plus 1 by 128 plus 1 by 256. Or else you can take 2 inverse plus 4 inverse plus 8 inverse plus 16 inverse, 32 inverse. Like that you can calculate. You will calculate, or I need to calculate?
Will do, sir.
Calculate.
$1.97 milliamps.
1.97 milliamps. See, I had given maximum I out will be your 1.9 milliamps you are going to get. Okay, this is a maximum current you are going to get. Can you check for the minimum? How you are going to check minimum? 0, 0, 0, 0, 0, 0, 0. Everything you have to give 0. What you will get?
0 only, sir.
0 only get. So that the output current will be vary from 0 to maximum of 199 milliamps, 1.99 milliamps. 1.99 milliamps in the sense it will be a digital data of 255. That is 11111 all ones. If I am going to give all ones, you will get a maximum current. If I am going to give a 000, you will get a 0 current I am going to get. That is output analog current will be my 0. So that it will be vary from 0 to 1.99, sorry, or else 2 milliamps, almost equal to 2 milliamps it will be going to get. Okay, clear everyone?
Yes, sir.
Okay, take next. How exactly you are going to get this formula? How you are going to get this formula? I out is equal to I reference. This relation I'm going to get like this. Okay, this is the R2 2R ladder network where I'm going to use. Here inbuilt of your 0808, inbuilt of your 0808, we have this circuit. Based on this circuit, if I'm going to give an inputs, it will be going to convert. Here with respect to the output, we are going to get a current. Okay, this is your R2R ladder network. Here are two different types of digital to analog converter. We have binary weighted resistor and R2 2R ladder network. We are going with R2 2R ladder network. Why? Because we are going to get a precision and accuracy. We are going to get a more. Here it will not require much greater values of a resistor. Here we are going to use 1K and 2K resistor, but in the weighted binary weighted resistor, it will be keep on increasing the resistor values for the network. Here some R to RR network, R to 2R network, like that 1 2 3 4 5 6 R network we have. There also we will get R 6R network, but here RR 2R R 2R you are going to use, but there it will be keep on increasing R and R 2R R 4R R 8R 16R, 32R, 64R, like that it will be going to increase the value of a resistor. But we are not available with the maximum value of a resistor. That is why we are going to, preferably we are going to deal with this concept. Okay, make a note of this diagram. By make use of this only, we got this formula. That is I out is equal to I reference into so and so. Okay, no need to explain these R to R ladder network in the exam. Just for the knowledge purpose, I have given this. You are going to study in detail in your analog circuits 5th module, maybe, and in the analog circuits lab also. Next, after this, we'll discuss the program. Make a note of this. Or finished.
Yes, sir.
Okay, now take for the circuit of the figure, find the maximum output amplitude of the sawtooth waveform obtained with the following program. 18 means this is the figure. For this figure, I had given a question. Find the maximum output amplitude of a sawtooth waveform obtained with the following program. So trace the program, and here I had given the solution. Here the method to generate the sawtooth wave is to increment the A register from 0 to FF to 0 continuously. In this case, the maximum value of the digital number is FF. What is the meaning of this? Up counter what we discussed in the last module. The same concept we are going to use to generate a sawtooth waveform. Means it will be started with a 0, increasing, again it will be decreasing to 0, increasing to 255, decreasing to 0, increasing to 255. Continuously we are going to generate. For the first program, see, move A, #00H. Move port 1, A. I am going to load a 00 value to the port 1. Either it may be 1.0, 1.2, anything. Accumulator will be 0 to 7. Means it will be 8 bit. That 8 bit will be loaded to your port 1. Next, increment A. Initially, I am going to start it with a will be 0. Next, increment A, 0, 1. S jump back, again back, increment A, 0, 1, it will be changed to 0, 2. S jump back, 0, 2. S jump back, 0, 3. Like that, it will be keep on increasing up to 255. Like that, we are going to get a 0 to FF. In up counter, what we discussed in the last module, the same program for this. For this program, here I had given the solution. It will be going to vary from 00 to FF. That is the solution. And the trace for the second program, can you tell me the answer for second one? Move R0, 64H. I am going to load a 64 hexadecimal value to the R0. Next, move A, 00. Move port 1, A. Increment A. Compare jump if not equal to 0, A, R0. If it is not equal, go back. Then, if it is equal, S jump to repeat. Repeat the concept. What is the meaning? What is the output you are going to get? See here, what you have to do, you have to take the formula. I out is equal to I reference into D7 by 2, D6 by 4, D5 by 8, whatever I have given some formula that you have to take. Then you have to calculate maximum current. What is the maximum current you are going to get? 1.99 milliamps you are going to get. Okay, for that we need to get the output voltage. How to get output voltage? V is equal to I into R. V is equal to I into R we need to take. So that we will get V naught is equal to I naught into R. What is the R value I need to take? What is R value? To get an output, I have used 5K feedback resistor. Use 5K. R value 5K you have to use. If I am going to use 1.99 milliamps into 5K, you will get a 9.96 volts you are going to get. Means it will be vary from 0 to 10 volts. Binary or hexadecimal equivalent to 0, 0 volts. And hexadecimal FF or 256 of a decimal, it will be equivalent to 10 volts in terms of voltage. See the solution here for the second one. Like that, for the standard value I have calculated. But in this problem, in this program, what they had given a maximum value will be 64. 64. For that 64, frequently 64 hexadecimal will be binary of 0110 and 0100. This we are going to use in this formula. Then we need to find the output current as well as the output voltage we need to find. If 0 equivalent, 000 equivalent is 0 voltage, 11111 equivalent of 9.96 voltage, but it is 64. 0 to 256, 64 will be a middle value. So that take the binary number of this and you substitute in this above equation, follow the same procedure, you will get a output voltage as well as output current. That output current will be 0.78125 milliamps and output voltage will be 3.9 volts for the respective digital hexadecimal value, that is your 64. It will be vary from 0 to 64 sawtooth waveform you are going to generate. Got everyone? Any doubts? Any doubts?
No, sir.
Okay, please make a note of that. Then next I will give one program you have to trace. Over. Now, how you are going to check for the maximum value 1111, like that you have checked for the 64. Take one more hexadecimal value 89. Check the output voltage. How you are going to get? What is the value you are going to get? Hexadecimal value 84. Equivalent of 84 or 88. Anything, any one number you take the binary bits of that and check for the value. See, it's not a mandatory to ask 64. Any number they can ask in the exam. Check for 89. What is the binary equivalent of 89?
One triple zero 1001.
Yes.
Yes, sir.
1/2 plus 1/32 plus 1/56.
0.5355, sir.
Yes, sir.
How much?
0.5352.
5352 milliamps.
Yes, sir.
You check properly. For 64 you got 0.7 milliamps.
So 1.07 milliamps.
1.0?
7 milliamps.
Yeah. 1.07 milliamps into 5 volts into 5K. 5.35 volts you got now output voltage.
Yes, sir. 5.35 volt output voltage.
Yeah. ಯಾರು ಅವಾಗಲೇ 0.8 ಹೇಳಿದ್ದು ಚೆಕ್ ಮಾಡಿದ್ರಾ ಜೈಸನ್?
Sir?
Got the correct answer?
Yes, sir, got.
Okay. We'll go for next. Okay. Trace this program. The circuit connect a switch to pin port 0.0. Write a program to do the following. When switch is equal to 0, DAC output gives the staircase waveform. When switch is equal to 1, DAC output gives a triangular waveform. Can you trace this program? See, for the staircase output, we are going to decide for the 5 steps. We are going to design. See the solution part I have designed like this. Let us design a staircase waveform for 5 steps. It means that it's a maximum value is 255. I'm going to divide by 5. I'm going to use only 5 steps with a staircase. 51 we are going to get. After the maximum value is reached, then output drops to 0 and it will be starts with a next cycle. 0 to maximum, maximum to 0, 0 to maximum. Like that it will be going to take the staircase. That staircase output we can call it as a quantization output. Quantization output you are going to get in the form of staircase only. By make use of that staircase only we are going to find the delta value, mid-thread or mid-riser. Mid-thread will be horizontal line, mid-riser will be vertical line we are going to consider, delta and delta H. That you are going to discuss in depth in, I think in PCS you will have, or in digital communication. Trace this program. See what we discussed, up counter, down counter, BCD up counter, BCD down counter. The same procedure we are used here, but as our convenient we are going to change the values. By make use of that we are going to, means it is when you are going to give switch 0, what is the output we need to get, that we are going to assign. When you are going to take switch is equal to 1, means we are going to set the ports, which port it will be working as a 0 and which port is working as a 1. Trace this program. It's very, very important program. So initially we are going to take switch equated to port 0.0, means we are going to assign the port 0 we are going to use. Then org00h set bit switch, we are going to set the switch to make an input port. Port 0 will be as an input port. Move C comma switch. Okay, move switch to carry. We are going to set with a switch. Jump if no, jump if carry. It will be carry. It will be going for here. Move A comma hash 00. Move port 1 comma A. Whatever the data in the accumulator, that will be loaded in port 1. Then increment A. This will be going to take a triangular pulse. It will be keep on increasing. Compare jump if not equal to A. It will be reaching maximum 255. It will be starts at 0. Okay, if it is no carry, it will be going to continue with that. Move A comma 00. Move port 1 comma A call delay. If it is port 1 will be generated with a 00, it will be taking some delay and it will be going to run the program. Then it will be going to return back. Then it will be going to return, means after A call delay, it will be going to take a add A comma 51. For 0, it will be going to add 51. Like that, it will be adding 5 times. First time 0, 51. Again, it will be going to take, it will be going to load with a 51 will be loaded in the port 1. Again, A call delay, it will be getting delay for some time. See, after 0, it will be going to take delay. After adding 51 to take delay, again it will be keep on repeating. After that, it will be going to take 0 plus 51 plus 51 plus 51, like that it will be going to take 5 times. Then it will be reaches to maximum. When switch is equal to 0, you are going to get a staircase output. When the switch is equal to 1, it will be working with a triangular waveform. This program, it will be working for triangular from 00 to 255. For each step, it will be incremented with 1. This is your up counter program. This is your up counter program. This is also up counter program with a step of 51. Like that, we made the program. Any doubts? Got everyone?
Yes, sir.